In this video we are going to discuss about the pass transistor logic. On completion of this topic, the students will be able to write the equation of the source to drain current, the three regions of the operation of mass transistor. So this pass transistors, pass transistor, why we are using is it is to require that reduce the transistor for implementing the logic by using the primary inputs, that is to drive the gate terminals, source and drain terminals also. So in complementary CMOS logic, primary inputs are allowed to drive only gate terminals. So here you can see the figure. It shows the implementation of the AND function using only NMOS pass transistors. In this gate, if the B input is high, the left NMOS is turned on and the copies to the input A to the output F. So when B is low, the right NMOS pass transistor is turned on and passes a 0 to the output. So this satisfies the truth table reproduced here. So major advantages of this pass transistor is that fewer transistors are required to implement a given function. Also, to illustrate this, we are considering the implementation of the AND gate using the complementary CMOS logic. If we compare this with the same AND gate, this implementation using the pass transistor logic, and the number of transistors required are 4, including the 2 transistors required to invert the input B. So another advantage of this pass transistor logic is the lower capacitance because of the reduced number of the transistors. So as discussed, these NMOS devices are effective in passing strong 0, but it is poor at pulling a node to VDD. Hence, when the pass transistor pulls a node to high logic, the output only changes to VDD minus VTH. So this is the major disadvantage of this pass transistors. And also this applications can be used in the fewer transistors that can run faster and also requires less power than the same function which are implemented in the same transistors. So here you can see the source is grounded, and what if the source if it is greater than the 0, that is example the pass transistor which is passing through the VDD. When VG is equal to VDD, if V is greater than VDD minus VTT or VG is less than VT, this transistor could be turned off. In the case of the NMOS pass transistors, it can pull no higher than VDD minus VTN, so we call it as degraded 1. Since it is degraded, it is gradually decreases slowly, and the PMOS pass transistors pulls no lower than VTH. So here is the pass transistor circuits. So this pass transistor circuits are used to indicate the style of implementing the logic gates that uses the transmission gates composed of both NMOS and PMOS pass transistors. So this pass transistors indicates the style of implementing the logic gates where each gate consists of this NMOS only pass transistor network followed by the CMOS output inverter. And here it is shown the diagram of the pass transistor, that is VDD value and VGS value. And the effective resistance. So this effective resistance is having the limited value. It is not accurate enough for the modern transistor, are also so complemented. So this complicated is due to the hand analysis, and simplification is this transistor can be act as a resistor and replace this with effective resistance. So IDS, VDS, VGS. So IDS is equal to VDS by R, and the average, it is this resistance is the average over switching of the digital gate, and is too accurate to produce the current at any given time, but that is not good enough to produce the RC delay. Quiz questions on the CMOS transistor, that is draw the DC transfer characteristics of the CMOS inverter. Thank you.